Hi, my name is Vincent, and today I want to take a look at using the chain rule. So we have find the derivative of the following function, and we're looking at f of x equals x to the third plus 7x raised to the 20th power. So for this problem, we want to avoid multiplying x to the third plus 7x by itself 20 times. To solve the problem that way, it would take forever. So we want to make use of this chain rule because it'll speed up the rate at which we could find the derivative of this function. So the chain rule states if y equals f of g of x and u equals g of x, then y equals f of u and dy dx equals dy du times du dx. And now what this means is, if we want to simplify this, if we have a composition function, what we could do is we could break the derivative into two steps and multiply them together. For instance, let's say we knew that y changed 5 times as fast as u changed. And we knew that u changes 3 times as fast as x. Well, then that would mean that y changes 5 times 3, or 15 times as fast as x. So by breaking this into two steps, we could find dy du and then multiply that by du dx to find the derivative with respect to x of the function we start with. So what we need to do is we need to make a substitution of some sort. So the best way to learn the chain rule is by example. So we're starting with f of x equals, and now we have x to the third plus 7x raised to the 20th power. And what we want to do is find the derivative with respect to x of both sides. So we're taking ddx of both sides, and we'll call this step 1. So now the substitution we want to make is we're going to let u equal our function of x, but we're going to call u x to the third plus 7x. So we have u equals x to the third plus 7x. So now what this allows us to do in the next line of this problem, we're going to look at ddx of, and now instead of x to the third plus 7x, we're going to just call this u. So we have u to the 20th power. So now this is where the chain rule is going to come in. We have, instead of looking at dy dx, now we're going to be taking the derivative with respect to u of y. But remember, y is our function of u, so what we're going to do for the next line, we have that this is equal to d du of u to the 20th power. Because notice how here, instead of this piece y, we just have d du. We don't have dy du because y is equal to our function of u. So we have the derivative with respect to u of our function of u, which is u to the 20th power. And now we need to multiply by du dx. So while this step may seem a little bit abstract, what always helped me understand this is notice how these du's would cancel out. The du in the denominator and numerator would cross out, bringing you right back to ddx. So just pay attention to that concept of multiplying by conversion factors. Those would just cancel out. So now we need to find du dx, because this we could find the derivative of. But what is du dx? Well, we're going to focus over here on this substitution we made. We're going to find the derivative with respect to x of both sides. So we're doing ddx of u, which is really du dx, equals ddx of x to the third plus 7x. So on the next line here, we'll make a little separation. We have du dx equals, and now what is the derivative with respect to x of x to the third? That would be 3 times x to the 3 minus 1, or 3x squared. And now we have the derivative of 7x. We have 1 times 7 is 7. And now we have x to the 1 minus 1, or x to the 0. So all we're left with is 3x squared plus 7. So for the next line of this problem, what we want to do is we're going to take the derivative with respect to u of u to the 20th power. So that would be 20 times u to the 20 minus 1, or 19th power, times du dx. So now we can finish this problem. Now we're going to substitute back in because remember, we're finding this derivative with respect to x. So now we want to make our substitution. We have 20 times u to the 19th power. So we have 20, and now remember, u is equal to x to the third plus 7x. So we have x to the third plus 7x to the 19th power. And now times du dx, but we found du dx to be equal to 3x squared plus 7. So this is all times 3x squared plus 7. So our final answer, I'll just write this really big. We have dy dx, because remember this was all, or ddx of f of x. We could call it dy dx, or we could call it f prime of x. So we have f prime of x is equal to 20 times x to the third plus 7x to the 19th power times 3x squared plus 7. So over time, when you get better at using the chain rule, you'll literally be able to look at this and just say, oh, okay, 20 times x to the third plus 7x to the 20 minus 1 to the 19th power, and then multiply by the derivative of the inside, 3x squared plus 7. But it is good to understand how to use the chain rule by definition, because it's a springboard to topics like implicit differentiation, related rates, so understand the definition of the chain rule also. Okay, well this is going to conclude this video on using the chain rule. Thank you all for watching, and I hope that this was helpful.